Hey everybody, welcome to DirectX 11 tutorial 41. In this tutorial we're going to focus on some code cleanup, and we are also going to look at getting a little more detailed error messages. So in our graphics CPP, one thing you'll notice is we have a lot of lines of code where it's just where we are checking the H result. So it's taking us 5 lines of code to check if HR failed, and then log our error, and then return false. We are going to look at making a macro to get this down to 1 line of code, and also at the same time giving us some more information back. So to accomplish this, first we are going to create an exception class. We're going to call this ComException. And the class is going to look like this. We need to include ComDef, so we can use ComError, and then string converter. Our ComException constructor will take in an H result, our message, and then the file the error occurred in, the function, and the line. Now what we are doing is we are going to define a macro called ComErrorIfFailed, where we just pass in the H result in the message. And what the macro will do is, if the H result is a failure result, then we're going to throw a ComException where we have that H result, the message, the file, the function, and the line. Now, file, function, and line here, these are actually macros. And anywhere that we have this in the code, it will give us back a string with the file name, the function line, or the function name, and then the line number. So basically we are building this string called whatMessage, and when they call this what method, we will just return back that string. So just to demonstrate this, let's set up a function in our error logger to take in the ComException. So let's go to the error logger, and we can take out string converter since the ComException header has that. And let's include ComException. We're going to add a new function for logging that. So let's go ahead and add a new function, and this will just take in the ComException. And now let's create the definition for this. And all we will do is we will get the exception message by calling what, and store that in error message, and then we will pass that into a message box. So let's just test and see how this error message will look. So let's say that we create a ComException object, call it exception, and for the H result we pass in 0. For the message, let's pass in test message. For the file, we will pass in the file macro, the function macro for function, and then the line macro for line. And then we will, on our error logger, we will log that exception. Let's see what we get. Alright, so we get our message, test message. The actual message from the ComError was the operation completed successfully, so we got that. And then we get the file the error happened in, the function it happened in, and the line number. Let's press OK. So we had that macro that we had created in the ComException header. And the idea of this macro is it will pass in the file, function, and line. All that we need to do is pass in the H result in the message. And it's actually going to be throwing ComExceptions, so we can just use a simple try catch to just skip, display the message, and then return false if something happens. So let's implement this. Let's go to the graphics CPP and go to, let's first do it for initialize scene. So we're going to put in our try, and then go to the end of our function before we return true. Then we'll put our catch. We're catching a ComException. And if a ComException happens, we want to log it, and then we want to return false. Because if an exception happened, it wasn't successful. Now what we can do is all of these if failed HRs, start at the first one, we can just change this to be com err if failed. We pass in the HR and then we have our message. Failed to initialize vertex buffer. And we'll just do this for each message that we have. Alright, and if any of these H results fail, then we will go down to our catch block, and we will log the message, and then we will just return false. So we've already got rid of about 20 lines of code just by doing that. Now let's apply the same thing to where we are initializing DirectX. So for initialize DirectX, let's go ahead and put our try block. And then go to the end before we return true. Going to put our catch. Alright, and now we are just going to go from top to bottom, and let's replace all of these if failed HRs with com err if failed. Alright, so we removed a lot of lines there. Let's see. So now we're down to about 382, but we can still get it down quite a bit more with some other changes. So the first change we can do is for the swap chain description, we are zeroing the memory on a separate line. We could just set it equal to 0 like that, and it will do the same thing. It will initialize all of the elements to 0. So then we can get rid of that 0 memory. Next, if we go down to this, where we are creating this 2D texture for our depth stencil, there is actually something. See, we are using D3D11 texture 2D, but there is actually a class for creating these just with less code. So let's say we use the CD3D11. And it's actually the texture 2D description. Alright, if we use this, the purpose of these is they have constructors we can use that help initialize a lot of the values. Because a lot of times, a lot of these values will be the same. So let's hit F12 and look at these constructors. So the constructor we're going to be looking at is right here. So we'll need the format, the width, the height, and then the rest of these values will be, if we don't pass in anything, they'll just default to these. So array size 1, that's fine. MIP levels of 0, we're going to change that because we want it to be 1. A shader resource, let's see, we actually want it to be a depth stencil. So we'll change to bind flags. Let's see, the usage is default, that's fine. CPU access is 0, that's fine. Sample count's 1, that's fine. Sample quality 0, and miss flags are 0. So that's all fine. So if we go back here, start this constructor. So the first thing was the format, which we know we're using this format. Then we have the width, which was the window width. And then we have the height. It's the window height. So we can take out the window width, window height, take out the format. The MIP levels in the constructor, it defaulted them to 0, and we actually want that to be 1. So we're going to keep this line where we're setting the MIP levels. Array size defaults to 1 in the constructor, so we can take that out. The sample description, count, and quality are the same in the constructor. The usage is the same. The bind flags was different. They used a shader resource. We are using the bind depth stencil, so we will keep this line. And the CPU access flags and miss flags were the same, so we can take those lines out. So we just cut down like, I don't know, 6 lines of code or something like that. Next, let's take a look at the depth stencil. So for this, once again, we can use cd3d11 struct. And let's take a look at the constructors. So some of these, the way they work is, you could pass in everything like this, but we don't want that. And then they also have these default values. If you pass in D3D11 default, you can call this. So in this case, all of these values are actually exactly what we want, except for the comparison. We were using less or equal, and really we can use less, so it's not a big deal, but I'm going to change it to be less than equal. So in order to call this constructor, let's go back. What we are going to do is we're going to pass in D3D11 default. And what this will do is it will call that constructor with the default values. And the only thing that was different than what we had was the D3D11 comparison less than equal. So I'll keep that line there. Next, we have the D3D11 viewport. And we're going to, once again, create a creation version of this. And let's take a look at the constructor. And this one's fairly straightforward. We just have the top left X, top left Y, width, height, and the min and max depth. We're not going to change the min and max depth. That's fine. But let's change the top left X, Y, width, and height. Or rather, we have to pass those in for the constructor, not really changing them. So 0 for our X, 0 for our Y, and for some reason, IntelliSense was pulling up the wrong constructor. Alright, our width is supposed to be a float in this case, so we'll need to do a static cast. And then our height, same idea. And then we can take out everything we had right here. And we can just say create and set the viewport. And there we go. We got that down to just 2 lines. Next, let's take a look at the Rasterizer Descriptions. Keep in mind, in the last tutorial, we made one for culling the front, and we have our default for culling the back. So let's create object for this. Let's look at the constructors. Now, our default one, it fills solid, it culls the back, the fronts are clockwise, just like how we have it, because they're false for counterclockwise, so they're clockwise, how we had it. And everything else is the same as what we had. So what we can do is, for the front version, we can just pass in D3D11 default. And we can take out everything there. And then I said for the front version, for the default version, like what we would expect, we can just do that. And then for where we want to cull the front, we will do the same thing, but the only difference is we will specify that we are culling the front. Alright, for the blend description and render target blend description, I wasn't really able to find a good creation struct for that. So I'm going to skip that one. And then down here, let's see, for the sampler description, we can save some lines here. So let's go ahead and create our create struct, and let's look at the constructor. So the filter is min, mag, mip, linear. That's what we are using. The address UV and W clamping is different. We were not clamping. Everything else is the same, so we won't have to worry about that. If we go back, we know that they were using clamping and we are using wrapping. So all that we have to do is keep the code where we are specifying wrapping, take out the other stuff, and there we go. We should be good to go. So if we scroll to the bottom, let's see. Now we are at 346 lines of code, so we've already gone down nearly 100 lines of code. We can also shorten it even a bit more by initializing the blend description like that, instead of doing 0 memory. Alright, and we're ending at around 338 lines of code for graphics CPP. So that is all that we are going to look at for this tutorial. In the next tutorial, we are probably going to start looking at loading models and maybe setting up a resource manager.